Here we are going to see the topic weight and its relation between the Newton's law of gravitation. In definition, weight is the force of gravity with which an object of mass m was attracted to the earth. So, in previous years, we calculate weight as m times the mass times the gravitation acceleration, where we take the gravitation acceleration as 10 Newton per kilogram. And we say that, let's say we have a cow with a mass of 1000 kilogram. So the weight of cow is equal from m times g. The mass of it is 1000, and we take the g, the gravitational acceleration of the earth, as 10, and set that the weight of the cow is 10,000 Newton. This is the weight, and this is the force that the earth applies on the cow, attract it towards its center. Now in this unit, a second equation has been introduced for calculating the force of gravity with which an object is attracted to the earth. Now I have a cow here with a mass of, let's say, m. Of course, the cow is here. And I have the earth with a mass of e, and this is the center of the earth, and the distance between the cow and the center of earth is the radius of earth. So, from Newton's law of gravitation, I know that the force is equal to g and 1 times m2 over the distance squared. So now let's apply it. So I have m1, the mass of cow. I have the second mass, the mass of earth, over the distance between them is the radius of the earth. And we said that this is the force of gravity, which we call weight. And we calculate weight from the formula m times g. So from this equation, when the masses are cancelled, you see that the gravitational acceleration of the earth is equal to gravitation constant times the mass of earth over the square of radius of the earth. So if we take the mass of earth is known, the radius of earth is approximately known. So if we put these values, we find it approximately 9.8 meter per second square, which we take as 10 for easy to use. When discussing the acceleration gravity, it was mentioned that the value of g is dependent upon the location. So you have the maximum g value at the center of the earth. You see that here the distance to the center of earth is the radius. So it has the maximum value, which is equal to 10. So as you go further from the surface of the earth, the g value decreases proportional to 1 over r square. When you get inside the earth, go to the center of the earth, it decreases linearly, you see here, and gets 0 at the center of the earth. So that means that your weight is 0 at the center of the earth. Your weight is maximum at the surface of the earth, and it decreases as you go further from the surface of the earth. So from the formula, the gravitational acceleration depends on the mass of the planet and the dimension, the radius of the planet. So the larger the mass, the planet, the greater it has the gravity. You see that the earth has the gravitational acceleration with 9.81. At the sun, it has 270, Jupiter 23, and our moon approximately 1 over 6 of our earth. So when you take an object, let's say with a mass of 100 kilogram, it has a weight of 981 Newton on Earth. It has a weight of 27,000 Newton on Sun, 2,300 Newton on Jupiter, and 162 Newton on the Moon. So our weight changes, but our mass doesn't change because mass depends on the amount of matter we have. Now let's do an example. Compute the gravity for the surface of a planet whose radius is twice that of Earth and mass is 3 times of Earth. So it has a gravity which is equal to G times 3m Earth over 2r Earth square, which is equal to 3 over 4 gm Earth over radius Earth square. This value is the gravity of Earth, which is equal to 10 meters per second square. So this planet has the gravity equal to 30 over 4, which is equal to 7.5 meters per second square. Another example, compute the G for the surface of a planet who has the radius half of the Earth and mass double the Earth. So let's put the formula. The gravity of planet is equal to G times mass to me over the radius square. So I have 8 gm Earth over r Earth square. So this is equal to 10. So this planet has a gravity of 80 meters per square. Now let's review the topic. So I have the Earth, and at the surface of the Earth the gravity is equal to 10 meters per square. So when I go through the Earth to the center, the G decreases directly proportional to the radius. Let's say when I came here to the halfway of the radius, then my G will become to 5 meters per second square. If I go further, let's one more radius of Earth square. So my G value will be equal to, from the formula, gm Earth over 2r Earth square is equal to 1 over 4 of the gravity at the surface. So it will be equal to 2.5 meters per second square. So the gravity depends on the mass of the planet. As the mass of the planet increases, it increases, and the square of the radius of the planet, when you increase the dimension, the gravity decreases.